Hello, everyone. We will wait a couple of seconds for everyone to join. This should be fine. Everyone can just get along. So welcome, everyone. My name is Britt, and I'm the marketing manager at Eatron Technologies. We're very excited that you're here. If you've been with us before, welcome back. And if it's your first time, welcome. You can see all the previous ones on Spotify, YouTube, and on our website. So these Talk to an Experts happen every last Thursday of the month. So make sure you stay tuned and follow us on LinkedIn, and then you will find the calendars there for our next talks, because we will cover anything automotive and anything technical, anything on the business side, whatever it is, we will cover it at some point, so stay tuned. So for those who don't know us, Eatron is an international technology scale-up, and we are dedicated to making software-defined vehicles a reality for OEMs worldwide. So our house rules, for if you haven't been here before, if you have any questions, just pop them in the chat, and Brian will answer them at the very end. So our expert of today is Brian, technical leader in motion control. So hi, Brian. Could you please introduce yourself?
Yeah, sure. Okay. Yeah, good to be here today. So I am technical leader for motion, and my background is just over 25 years in automotive, and mainly in vehicle dynamics development, so passive systems, and then into active chassis control systems development, integrating them, developing them, calibrating them. And also then spent 7 or 8 years in ADAS and automated driving. So again, that kind of went on from the vehicle dynamics side of motion control into more advanced motion control. And now, I'm back into motion control for vehicle dynamics predominantly here at Eatron. And my role here, I'm the technical lead for the area. I work with a team of software engineers and system engineers here to develop the software solutions for us. We're involved in different kinds of motion control here, from damper control through to some more advanced stuff, which we'll hopefully get a chance to talk about today. So, yeah, nice to be here.
Cool, thank you. So let's dive straight in. What is active suspension and what is possible?
Yeah. Okay. So I've got a few pictures which we've used in some presentations recently, so I thought it might be useful for some of this.
Okay.
So just in terms of active suspension, I guess there's a range of things that it covers. It covers everything from air suspension, which is adapting the static spring force in the suspension, or it can adapt the spring stiffness, through active dampers, which are able to change how much suspension damping there is in the vehicle. Active roll control, adapting the roll moment, and then what some people would call fully active suspension, where it's possible to actually overlay a force on each corner of the car. So we would consider all of these to be active suspension systems. And within each of these groups, there's a range of capability possible. So it depends on the supplier or the technology that they've chosen. But there's typically a range of performance possible through either different bandwidths of the system or response times and those kind of things. So if you look at active damping, for example, there's a picture there of one active damper, which is a kind of conventional hydraulic damper with a bypass valve control. And the other one is a magnetorheological damper, so an MR damper, which so these two have a very different characteristic, but are kind of within the active dampers technology part. So the thing with all of these active suspension systems is that they give the OEM greater tuning flexibility when the OEM's trying to optimize comfort and handling and steering behavior in their vehicles.
Okay. So like picking an active damping, then why would I? Well, an OEM. Why would they need it?
A good question. So I think if we think specifically about the EV market, that's a big area for us at the moment. I think there are probably three drivers or benefits that I would see going to an active damping system. The first one is about these new EVs. A lot of them are being positioned to compete against premium products in the premium segment, where having the right level of feature content, the right technology on the car is very important to the consumer. So some of it is about just positioning of the product in the premium segment. Active damping's available or has been available for a number of years on a lot of premium products. So that's the first one. I think secondly, again, it's important for vehicles to have the latest tech and also to provide the consumer with the latest, the best experiences they can have. And part of that is being able to give the customer choice or personalization. So in the case of active damping, that allows the OEM to offer the customer different modes, like a sport mode or a comfort mode in their car.
Oh, is that just with when you press the button to put it like comfort mode or sport mode? Is that a change of the damping then?
Yeah, so when a car has changeable driver modes, if it's got a comfort mode, then typically dampers are one of the systems which will be adapting for that mode. So it might also they might change the way that the vehicle responds to throttle inputs or brake inputs, or maybe the feedback through the steering wheel. But yeah, the active dampers will change typically in those different driver modes as well.
Okay, thank you.
And then the third reason, kind of more of a technical reason for EVs needing active damping, is to do with the mass properties. So what we see in the market today is typically with EVs, if you compare it to a petrol or diesel derivative of the same vehicle, the EV will typically be between 20 and 30% heavier. So the vehicle has higher mass. And although it's got higher mass, because of the positioning of that mass, some of the other properties, the inertias of the vehicle, are maybe not so high or are different. And that difference in mass properties and the balance between masses and inertias makes it more challenging to achieve the same kind of feeling in the car that you have on the equivalent ICE derivatives. So that different challenge is more difficult to kind of manage with a passive system. So that's where to achieve the same kind of balance between comfort and handling, an active damping system can make a real difference to the OEM.
Okay, and what would you say are the most important things to get right when you integrate an active damping system?
So I think there's a few things. So first of all, integrating any of these active systems into the vehicle in itself is a challenge. So there's some challenges with packaging, managing power consumption of these systems, managing the kind of duty cycle and the durability of them. So there's sort of normal integration challenges. Then there's how to pick the right system design. So that includes the right sensors, how many sensors are needed, and what specification of sensors, but also the actuator. Like I mentioned earlier, there's different types of actuator, even within these different groups. So picking the actuator with the right performance, along with the sensors, is really critical. And that again is a challenge. So it's about the overall system design for what's needed. And then finally, I think, big challenge, and where we at Eatron kind of put a lot of our value in, is picking the right control strategy or the right control approach. So in terms of integrating systems, there's two areas here. There's one is if the customer or the OEM has a number of these different active systems working on one vehicle, it's important to integrate the control of those systems to avoid fighting between each system, but also fighting between systems, but also maximising the kind of benefits that are possible between across all the systems. And then so the other part of the control approach really is then how do you get the right performance that you want from these systems? And that's where so we have Eatron, we kind of think about it. If we're trying to achieve kind of two goals from the OEM side, one is for comfort and one is for handling. We think about kind of skyhook and ground hook control principle. So if you think about comfort, think about skyhook, you're kind of optimizing the performance of the vehicle for maximum comfort, and you want to try and achieve this kind of situation where the body of the car, the occupants are kind of gliding across the surface.
Like a Mercedes.
Yeah, so a Mercedes, if you think about a Mercedes sedan, you think of a nice, comfortable vehicle, and the occupants are kind of gliding across the surface. And it's similar if you think about the way that I like to kind of picture it is if you watch a film with a big cat in Africa hunting, and it's kind of moving across the surface following its prey, its legs are going crazy. It's kind of moving around, but if you watch its head, it stays absolutely level. It's locked on the prey, and that's like kind of same behaviour you want in the vehicle. You want, if the body of the vehicle, the occupants, you want to be like the head of that big cat, staying absolutely level while the wheels are going up and down, over the road surface. So that's what we would call a kind of skyhook kind of behaviour. And you're kind of anchoring the body of the car to the sky. And then the other side of it is if we're focusing on handling, then that's where actually it's the opposite end. We want to give good connection feel for the driver. We want an engaged driving experience. You want the wheels to be connected to the road. So you want the wheels to follow the road surface as well as possible. You want consistent force in the tires,
like a Porsche.
Yeah, exactly. So Porsche, if you think again for Porsche, then you think about the driving experience is more about connection and being stuck to the road, and that comes through this kind of ground hook approach where you're anchoring the wheels, the unsprung mass, to the kind of road surface. So these two kind of ideas, or these ideologies or principles are the kind of comfort and handling focus. And what we do here at Eatron is we've got a control approach as a hybrid of these two methodologies, which then makes it kind of easy to balance then between, so that there's a tuning kind of flexibility there. And also, as we said earlier, with the driver modes, you can adapt maybe in a sport mode to be more like a ground hook kind of focused control. So that's makes it easier to calibrate, and that's how we would approach it. And yeah, so all about, again, with these active systems, trying to find the right balance, and trying to maximize the benefits that you can get from these systems.
Okay, and so I've heard about more advanced features in some cars using ADAS sensors and map data. Why would an OEM need this?
So what we see is in this sort of area, there's a couple of different areas that it can help the overall performance of the system. So one area is it can help absolute performance. So in this area, it's kind of helping with the perception of the system. So we've got these sensors on the vehicle trying to sense what's going on with the wheels and the body. But if we can look ahead and kind of give a prediction of what's going to happen from these this other information, the ADAS sensors, for example, use a camera for looking at the road surface ahead. The map data could have historic stored data about road surface condition or speed bumps, things like that. And that improved perception that comes from integrating or fusing all of that data means that you can be more certain what's actually happening at any time. And then the other way is that so that's the kind of perception, making sure the inputs to the control system are better quality. And then the other part is in the control system itself, in the decision making. Then with more data and more confidence in the kind of scenario around the car, you can decide better what the right control approach is. So if we might be conflicting, the one set of sensors thinks that the right thing to do is to minimize the damping because of particular wheel movements. But if we understand it from the situation that we see from the external sensors, the ADAS sensors and the map data, actually something's about to happen, then we can it gives us a better idea to ensure the correct control used at any particular time. So there's kind of two areas where it can help.
Okay. A side question: where does the map come from?
Good question. So there's a number of map providers who support OEMs. So the traditional navigation map providers have a map data that is put on the vehicle, and normally that will be regularly updated on any vehicle. And these companies that manage the map data can also manage additional data. So typically that kind of map data will cover things about the route, the type of road and the curvature and things like that. But we can add in extra information onto that map. Just like you see on Google Maps, for example, where you've got the traffic information kind of live.
Oh yeah.
That's kind of added information on your map that you see on your phone. We can add in information about speed bump information, so positions of speed bumps, dimensions of speed bumps, those kind of things. And again, by having the car kind of connected to the cloud, then the vehicles can be updating that information regularly as well. So the map stays up to date, and is kind of fed back to the vehicle in a kind of a continuous kind of loop.
Okay, and what about the sensors? What type of sensors are there on the car?
So we've got the suspension systems themselves have their own sensors typically. So there will be some sensors that are measuring suspension movement or displacement. So they might be accelerometers or displacement sensors. There's also some other sensors in the chassis system looking at the body movements in terms of, again, accelerations and rotations and things. And then in addition to that, these ADAS sensors that are typically useful at the moment, predominantly camera systems are good for surface scanning. Some companies have used LiDAR scanners as well. So there's different types of ADAS sensors that will typically be on vehicles these days, with a lot of more legislated ADAS systems being required, means that vehicles are equipped with these kind of capabilities already. So using them for suspension control is, it seems like a natural thing.
Cool, thank you. Well, that was the talk, everyone. Let's look at the questions. Oh, we've got a lot of questions already, actually. Are you ready to answer them?
Yeah, give it a go.
Let's see. Oh, Seren is saying, could you give us specific differences between air suspensions and the other active suspensions?
So if we think about air suspension on its own, what the air suspension is, it's typically replacing the coil springs of a suspension with an airbag, where you can adapt then the pressure in the air spring to adjust the static load that spring provides. So that an air suspension system is a relatively kind of low frequency system. It's predominantly there to compensate for load changes in the car, to maintain the car at a consistent ride height, or it can be used to adjust the ride height, maybe with higher speeds. You want to drop it to improve the aerodynamic properties. So the air suspension is very specifically for those kind of scenarios, whereas the other active suspension systems are more dynamic in their reaction. So they'll be, the active damping systems, sometimes called continuous damping control. So they are being adapted continuously as the car is driving to change the damping level for any situation. And similarly with active roll and more fully active actuators, they're dynamically changing the roll moment or the forces in the wheels to react to certain situations. So the air suspension, although it's an active system, is really aimed at a very different kind of use case than the other systems.
I hope that answers your question. Christoph is saying HV battery in EVs is typically impacting vehicle center of gravity and potentially rigidity of the chassis comparing to ICEs. How does it affect the performance of the active suspension?
So I think I mentioned a little bit earlier about the mass property differences. So we do see, the center of gravity typically can be lower with the introduction of a battery, particularly in a kind of skateboard architecture. But because of the positioning of the mass, we no longer have a combustion engine at one end of the car, which increases the inertia. So typically the pitch inertia will be lower on an EV architecture than on a conventional powertrain. But as I said earlier, typically the overall weight is higher. So there's some kind of advantages and there's some disadvantages that come from that. And what we have experienced as well is that it's that kind of combination of mass properties which makes it more challenging to get the same kind of character in a vehicle that you would have in a conventional vehicle. Now, that doesn't necessarily mean that the character of an EV is not going to be the right one, but what it means is there's a different challenge there, and the need for active damping becomes kind of more obvious. And obviously, rigidity comes into it as well, in terms of changing the modes that of the body. Again, it's not just the rigidity of the body itself, but the units, the power units, and things like that. They all have kind of frequencies, natural frequencies that they'll be resonating at. And again, we need to make sure that our control system can recognise those and adapt the damping where possible to improve that. I hope that's answered that.
Saran's asking another question. What is a domain control unit?
So it not specifically for suspension systems, but typically a domain controller would be an ECU, which is covering not just one single system, but is covering a number of different control systems or controlling different systems within a similar kind of functional domain. So we would, for example, ADAS, typically instead of having an ECU in the camera and an ECU in the radar, and maybe another ECU for the parking, a domain controller, an ADAS domain controller, would be one control unit which is controlling all of those different systems. And similarly for suspension, we're seeing more and more the control of dampers and air suspension and other chassis systems or suspension systems being brought together in a chassis domain control unit. So it's just about bringing together control into single ECUs.
Cool. Hope that answers the question. Adnan is saying, how can the dampers be more affordable so that it can be enable EV without compromising on cost?
Yeah, so that's a really good question. It's always a challenge, to increase the technology on vehicles, but try and still maintain a competitive cost. It's a big challenge. I mean, as with a lot of these electronic systems, what we're seeing though is that the longer they're in production and the components are developed further, they become more efficient in their design, and the costs come down. Active dampers, for example, have been around for a number of years now, so we are seeing that. But as with any active system, then there is there's a trade-off there. I mean, you do need to invest in the actuators if you want to have this kind of more advanced capability. But what we would see probably from the OEM side is that there's then an advantage to OEM. The consumer is getting more for this. So there's a way there then to offset that. The consumer may be more willing to pay, or it may be that there's more capability that's possible with this system. That means that the vehicle itself, the overall price of the vehicle, is kind of compensating for that.
Cool. Yigit is saying, what about big data? What does that look like for chassis control systems? Can fleet data be used to optimize control strategies?
Yeah, good question. So I think in terms of data, big data, I mean, we talked earlier about some of the the information about the external environment. So making sure that vehicle-based data, so whether it comes from ADAS sensors or the chassis sensors, is fed back to a kind of a cloud base where it can be stored normally as within a map database. So that can be used then to help build a better picture of the environment and how that can then be used in the control systems. But also these control systems, chassis control systems, have a lot of information about the vehicle, about the driver, what the driver's doing, how they're driving, and also about the systems themselves, the kind of inputs that they're experiencing. So really it opens up through this kind of connection and sharing data back from the vehicle. It opens up opportunities for the consumer to know more about how they're driving, perhaps, or what the vehicle's kind of performing like, but also for the OEM to get a better idea of how their consumers are using the vehicle, so it can help the OEM as well with maybe some decisions about changes that might be helpful to consumers on future products or on existing products.
Thank you. I hope that answers your question. David is saying, what is your view on fully active suspensions?
Okay. Yeah, good question. So I think, fully active suspension, there's a couple of examples in the market already. Have been for a few years. Mercedes have been putting a level of fully active suspension on their vehicles now for a number of years. I think what we tend to see with this, it's like in a lot of technology areas, the cost currently is still quite high for that more advanced actuation, and that for a number of OEMs and ultimately consumer is still prohibitive. So although they do provide some additional performance benefit compared to active damping, for example, there's a significant cost still required for it. So I think it's still technically can offer more benefit over an active damping system or a combination of active damping and roll control. But what we're seeing, we until the cost of the actuation comes down, then I think it's still going to be something which is only seen on a few products, more niche products, or OEMs who are really trying to differentiate themselves from the competition.
I hope that answers your question. Xenia is saying, which ECU is processing the road bump/pothole information? The ECU of camera or ECU of damper?
Okay, so this depends very much on the choice of the OEM. So how their architecture is set up. Typically, what we would expect though is that the processing, the image processing. So if we're saying it's a camera, for example, actually identifying the bumps and the potholes is something that's quite computationally is quite a task for an ECU, and the ECUs typically the ADAS ECUs, so either in the camera or an ADAS domain controller, will be more suitable for that kind of processing. So the kind of image processing typically will be done in the ADAS unit. The actual then what you do with that information, whether you choose to react to it, whether you choose to trust it, or whether you trust more the onboard sensors, the chassis sensors. That kind of decision-making part of the logic, that processing part, will typically be done in the chassis control domain, so either in the damper control unit or domain controller at chassis level.
We might go a bit over time, if you don't mind, Brian. There's a lot of questions that are coming in. If any questions don't get answered today, we will answer them in the chat, but everyone's questions will be answered at some point, but most of them today. Sarana's asking another question. Where do you get cloud-based road bumpy information and send directly over the air suspension unit on the car?
I think if I understand the question correctly, I think it's about which units are doing the connectivity here with the cloud. So I'll answer it that way. If that's not how it's intended, then please just add another question. So I think so typically there will be a unit on the vehicle, a control unit, which has the responsibility for doing the onboard offboard communication. So a telematics module which will handle that, and then on the vehicle, then that information can then be passed to the relevant units. So typically, again, if it's map-based data that's stored, it will normally be going to an ADAS unit. So the ADAS system will be using a number of an amount of data from the map anyway for ADAS control systems. So typically that kind of then will be managed within the ADAS unit, and then that information passed further on to the chassis control unit, typically. So normally the air suspension unit itself wouldn't be directly connected to the cloud. It will be getting the data from other units on the car.
Hope that answers. Oh, we've got another question. Is there a control unit to operate the air suspension related with chassis control package and ECU?
So yeah, again, I think it depends on the vehicle architecture. If a car has a number of different chassis systems, then potentially those will all be managed in a kind of domain control unit. So it could be that air suspension is handled within a chassis unit. What can also happen is that the air suspension itself, the compressor or the valve block, may have an integrated ECU. So in which case, it could be a dedicated ECU, or it could be that ECU then is used also to house damper control software. So it's really, there's lots of different kind of ways to allocate the software and to handle it on the control unit side. And again, it will be very much the OEM choice as to which suppliers they want to work with or how their electrical architecture is set up. So there isn't really one kind of answer to that.
I hope that sort of answers it though. Ilias is saying, how does the semi-active damping suspension system compares the fully active suspension system? What are the advantages of each solution?
Okay, yeah. So, right, how best to answer? So the with a an active damping system or semi-active system, as Elias calling it, the system can only change the level of damping in the suspension. So, and damping, to generate the damping force, you need some movement in the suspension. So the force that can be kind of controlled is really depending on movement of the wheel. But like I say, it can change the damping and therefore control the energy by adapting damping coefficient. Whereas with a fully active system, the idea is that you can actively control the force. So independently of whether the wheel is moving anyway, you can apply a force to individual wheels. So you can apply force. You can do that to try and control the position of the wheel, or to try and control the force in the tire. So there's a greater kind of capability in terms of actuation and the effect that has on the car with a fully active system than with just a semi-active damping system. The advantages are that, one significant one is the cost difference. Like I said earlier, that an active damping system is going to be lower cost, and you get a significant benefit in terms of the customer experience just with active damping on a car. Whereas the fully active system gives you much more capability to control the suspension forces and therefore the behaviour of the car. So you've got much more bandwidth with a fully active system. One kind of technical advantage of a damping system is that you still need damping in the suspension, and that with a fully active system you have to try and manage that in the actuator as well. So it's a kind of something which a conventional kind of active damping system, you don't have to think about it so much unless it's an MR magnetorheological damper, in which case that's a bit more challenging. But yeah, so it's hopefully a bit of a rambling answer, but a bit of an idea.
Yigit's saying, are fully active suspension systems safety critical? How do they look like from functional safety point of view?
Yeah, so it's a good question, and yes, they are safety critical. I mean, most of these kind of control systems are in some way safety critical. Controlling the suspension on the vehicle, can really influence the way the vehicle handles, and therefore how safe or controllable it is. So they are safety critical. How they look exactly will depend on the application. So you really need to consider the functional safety for the whole system in the kind of target vehicle. So the hazard analysis and risk assessment all has to take all of that into account. So it depends how that's done, and will be different, depending on the OEM and the application. But yeah, typically systems that have more actuation capability and can change the suspension more will have a higher ASIL rating than those that have kind of less effect. So
thank you. I'm not sure if I'm going to say the name correctly. I'm really sorry if I pronounce it wrong. Venugo Power saying, is there any development in the direction of having electric suspension instead of air suspension, which is heavier? Will it help in reducing the weight?
So if I understand, so the idea is that the electric suspension might be lighter than air suspension, I think is the kind of basis of the question. So I guess, one thing to say, I think air suspension is a very good way of doing what it needs to do today. So in terms of compensating for load in the car, maintaining level ride height, it's a very energy efficient way of managing that task. Whereas typically if you're trying to manage the load with an actuator like an electric actuator, then you'll probably be drawing much more power consumption. So it might be, overall, it might be a way of keeping the weight of the full system down by going to an electric actuator. I think it's unlikely. I think even weight-wise, an air suspension system probably will end up being less weight than a full electric actuation. But I think the other thing is, like I say, the power consumption, and I think the current concepts for active suspension don't kind of take away the need for that static force offset that air suspension is very good at.
Cool. We're going to answer just a few more. So if we don't answer your question, we'll answer it in the comments because we're going a bit over time. So let's say 4 more minutes and then we will stop. Naveed is saying, what are the cons in magnetorological suspension?
Yeah, so I think just looking at Naveed's previous comment to that, I think in terms of active damping and semi-active suspension, MR dampers are probably, in terms of their performance, better than a valve-based bypass system. So I think you're right in saying that they're maybe the most advanced in terms of that capability. Their reaction time, their consistency of response and control is very good. And the cons are that I guess one is, until now anyway, it's not been a very widely used technology, so the availability of it in the market is relatively limited. And maybe because of that as well, cost can be a consideration. They've had some technical challenges as well over the years, which have been kind of improved more recently. But I guess with fewer companies working on them, then the kind of advancements take a little bit longer. But I think the main con from a technical point of view is the fact that in terms of the base damping level of an MR damper, it doesn't have the kind of inherent damping characteristics that a bypass type system will have. So the control system then has to really be much more active in terms of providing just basic damping, which is really important for just this connection and the steering, the immediate movement from kind of straight ahead. So there's more of a challenge from a control point of view with MR dampers than with a conventional damper. I think that's probably the main kind of technical disadvantage.
I hope that answers your question. Joanna's saying future actions for reducing the weight by integrating the functions of all the components of the whole active suspension system.
Yeah, I think so. I think there's definitely some opportunities to help with complexity and weight by integrating systems together. So definitely, if the control can be integrated, then more is possible with the actuation, and therefore you could potentially look at maybe sizing differences of the systems to try and optimize the weight. And ultimately, if you kind of look at a fully active actuator, if you can get rid of an active roll bar and active damping, and then possibly integrating functions into fewer actuators may also eventually bring a weight benefit. I think in the short term, the kind of main advantages are if you can reduce the number of control units and the number of sensors used by all of these different systems, then you get a weight saving, and not least because of the reduction in wiring and things that you can see on the vehicle.
We've got one more question, and then we'll have answered all of them actually. Mohammed is saying, you've mentioned about potential usage of active suspensions to enhance ADAS capabilities. Another interesting example of this is the Audi A8 pre-sense side collision system, lifting up the side of the vehicle to mitigate the impact. Can you please explain this as well?
I'll do my best. So I'm not an expert in the Audi system itself, but I think so. There's a couple of things. So we there are things you can do with the suspension to kind of adapt based on an emergency or critical situation. So you can increase the damping, try and optimize the contact force of the tire when there's a critical situation, like an AAB braking event or something like that. The Audi, the pre-sense collision system. So again, from the information from the ADAS sensors about what's happening around the vehicle, they're using the fully active actuator. So they have a kind of force overlay actuator on the vehicle, and they're able to then change the height of the vehicle in the immediate kind of time before the collision to try and get the vehicle into a position where the impact energy is going to be managed, most efficiently. So it really depends on the kind of the collision situation, but they're optimizing the stance of the vehicle to minimize the energy in the going into the passenger compartment. And I think others do it as well, by the way.
Thank you. Well, I've learned a lot today, Brian, so thank you for your time. If there's any more questions, please pop them in the chat and they will be answered. So we hope to see you in the next live. Stay tuned on LinkedIn and have a nice day.
Thanks, Britt.
Thank you.